We want to work now with our half-angle formulas, and I've written our first problem over on the board. We want to say, let's let sine A equal 4/5 with A in quadrant 2 and find sine of A over 2, cosine of 2A. Well, sine of A over 2, this is a half-angle formula. I've memorized it, and so I know it's plus or minus square root 1 minus cosine A, all divided by 2. Now for my cosine 2A, that's a double angle formula. I've memorized that. There's a couple of different ways I can write it, but let's try this one. How about cosine squared A minus sine squared A? So either of these two formulas that I use, I'm going to have to find the cosine of A. I have the sine of A, so let's find the cosine of A. Cosine of A, well, I could draw one of my little reference triangles and do it that way. Let's try an identity here this time. Plus or minus, well, I know that A terminates in quadrant 2, so cosine is going to be a negative number. 1 minus sine squared. Well, sine squared is 16/25. So that's minus square root 25/25 minus 16/25 is going to be 9/25. And just as you'd expect, this comes out 3/5. Probably knew that it was going to be that anyways. So that comes out negative 3/5. Okay, so, whoops, something dropped. That's all right. Back to my original problem here. This is going to be plus or minus square root of 1 minus cosine A, and here I have cosine A, so 1 minus negative 3/5, so 1 plus 3/5, all divided by 2. Now let's see, this is 5/5 plus 3/5, that's 8/5 divided by 2 is going to be plus or minus square root of 8/10. So that, in reduced form, is going to be plus or minus square root of 4/5. And so that is going to be plus or minus 2 over square root 5. So this is the answer, except I need to determine what sign this is going to be. So let me go back up here and say I know that A is in quadrant 2. So that means that 90 less than or equal to A less than or equal to 180. And what I'm looking for here is the sign of A over 2. So I need to know the quadrant that A over 2 is in. So I'll divide all of these by 2. And I see that I have 45 degrees less than A over 2. I'll make that less than or equal to 90 degrees. So I see that A over 2 must be in quadrant 1 if A itself is in quadrant 2. So that tells me, because of this, that I'm going to choose the positive sign right here. So my answer is going to be 2 over square root 5. It's positive 2 over square root 5. So a little messy right here maybe, but the idea is this. I have this formula memorized for a half-angle formula for the sine of A over 2. Okay, so I write the formula down here. I say I need cosine. I go back up here and find the cosine of A, substitute it in, work out all the arithmetic. The last thing I do is decide, well, I need to determine what sign this is going to be, what algebraic sign. I go back and look and see that A is in quadrant 2. That means that A over 2 must be in quadrant 1. Let's try another problem. I have cosine 2A is cosine squared A minus sine squared A. So I'm going to write this as, let's see, cosine squared A. Well, I found that cosine A was negative 3/5 previously, and then sine squared A was, or sine A was 4/5. So I'm going to end up with 9/25 minus 16/25. So I should end up here with negative 7/25 for the cosine of 2A. So cosine squared A minus sine squared A, substitute in the values I have from problem number 1, get negative 7/25. So that's not too bad. Pretty easy. I think the double angle formulas are a little easier than the half angle formulas. Let's look at our last problem, which is secant 2A. I want to find the secant of 2A. Well, that shouldn't be bad because secant is 1 over cosine. So I have secant 2A is 1 over cosine 2A. I already found the cosine of 2A, so it's 1 over negative 7/25. And the reciprocal of that is going to be negative 25 over 7. So that's probably the easiest problem of the three, just using my reciprocal identity that secant 2a is 1 over cosine 2a. So that's a quick look at some half angle formulas.